Hi, today we are going to learn about solving trigonometric equations with infinite solutions. Let's look at a problem. Solve. Cosine theta is equal to 1 minus cosine theta. Cosine theta is equal to 1 minus cosine theta. Adding cosine theta both sides, we get 2 cosine theta is equal to 1. This implies cosine theta is equal to 1 by 2, dividing by 2 both sides. This implies theta is equal to cosine inverse 1 by 2. Now cosine inverse 1 by 2 is pi by 3. So the general solution is theta is equal to plus minus pi by 3 plus 2n pi, where n is any integer. Now negative pi by 3, if we see negative pi by 3 and we want to make this into a positive, we can take cosine in second quadrant. In second quadrant cosine will be negative. So negative pi by 3 in the second quadrant will be given by pi minus pi by 3, 3 pi by 2, 2 pi. Since angle in the second quadrant is given by pi minus theta, so the angle here will be 2 pi by 3. So we can say the solution is theta is equal to pi by 3 plus 2n pi and 2 pi by 3 plus 2n pi, which is the answer in the B part. Next problem. Solve. 2 sine square theta minus 3 cosine theta minus 3 is equal to 0. Let us turn this equation into cosine theta. Sine square theta is 1 minus cosine square theta. So 2 times 1 minus cosine square theta minus 3 cosine theta minus 3 is equal to 0. 2 minus 2 cosine square theta minus 3 cosine theta minus 3 is equal to 0. We can say negative 2 cosine square theta minus 3 cosine theta. 2 minus 3 is minus 1 is 0. We can take negative sign common. 2 cosine square theta plus 3 cosine theta plus 1 is 0. This implies 2 cosine square theta plus 3 cosine theta plus 1 is 0. Now factorizing this equation, we need the factors of 2 times 1, which add up to 3, which is 2 and 1 only. So we can say 2 cosine theta plus 1 times cosine theta plus 1 is equal to 0. This implies 2 cosine theta plus 1 is 0, or cosine theta plus 1 is 0. This implies, first of all, subtracting 1 both sides, we can say 2 cosine theta is negative 1, or here also subtracting 1 cosine theta is negative 1. This will imply cosine theta is negative 1 by 2, dividing by 2 both sides, or cosine theta is equal to negative 1. This implies theta will be cosine inverse of negative 1 by 2, or theta will be cosine inverse of negative 1. Now negative 1 by 2 is given by 2 pi by 3 and negative 1 is given by pi. Therefore, general solution will be for cosine inverse negative 1 by 2, it will be theta is equal to 2 pi by 3 plus 2n pi plus minus, and for cosine inverse of negative 1, it will be theta is equal to pi plus 2n pi. For negative 2 pi by 3, we can say the reference angle will be 4 pi by 3. So we can say theta is equal to 2 pi by 3 plus 2n pi, 4 pi by 3 plus 2n pi, and pi plus 2n pi, which is the answer in the D part. Next problem. Solve cosecant 4 theta, cosecant to the power 4 theta minus cosecant square theta is 0. So we can take cosecant square theta common. Let's factor it out. Cosecant square theta. We will be left with cosecant square theta minus 1 in the parentheses. Is equal to 0. So we can say either cosecant square theta is equal to 0 or cosecant square theta minus 1 is equal to 0. This implies cosecant theta is 0 or cosecant square theta is 1. When cosecant theta is 0, this is undefined because it is outside the range of theta. So we can say cosecant square theta is 1, which implies cosecant theta is equal to 1, which implies theta is equal to cosecant inverse 1. When cosecant inverse 1 is pi by 2, so theta will be plus minus pi by 2 plus 2n pi. Negative pi by 2, the reference angle will be 3 pi by 2. So theta will be pi by 2 plus 2n pi and 3 pi by 2 plus 2n pi, which is the answer in the B part. I hope you can practice more problems on solving trigonometric equations with infinite solutions now. Thank you for watching. Have a great day. Bye bye.